Welcome to Lesson 23. This is Tools and Methods for Conducting Quality Risk Management. In this lesson, we're going to be looking at the 10-step approach to QRM. We're going to be looking at some common quality risk management tools, some examples of implementation for QRMs. So this is a 10-step approach to performing a QRM. It's what we discussed in our previous lesson with just a little bit more detail around it. So the first thing you will be doing is collecting and organizing your information. Then you will be defining the risk question, choosing a tool, determining the risk factors, define the scales for the risk factors, define the risk terms and/or develop a matrix, determine the threshold for action, apply the tool, define what risk mitigating measures you will take, and document and approve your quality risk management. On top of this stands an ongoing risk review. Our first 2 points here are around the initiation of your QRM and what is your risk identification. The next part then comprises of our risk analysis. We've got a risk evaluation once we've done our analysis. What are we going to put in place to reduce the risks that we have identified? And then our output and our risk acceptance going forward. And standing on top of that then we have the risk review. So the first step on that process is to organize our information. So basic techniques are required to organize our information. We can use things like brainstorming, we can use things like flowcharts, check sheets, process mapping, cause and effect, the Ishikawa fishbone diagrams, control charts or Pareto charts, and the objective really is to methodically collect and get as much data together as we can to inform our decision and to organize that information so that we can easily see trends and information. We talked in our last lesson a little bit about the importance of how we define our risk question, making sure that we're covering the outcome, the scope, and the risk factors as part of that. The next step then, step number 3, is to choose the right tools. So we've talked a little bit about the different types of tools. There is no wrong tool. There are lots of different types of tools you can use. If you've got a simple problem, it makes sense to use a simple tool. The various methods of analysis are largely interchangeable, so you can use a component of one and a different component of another. Methods and tools can be modified to meet your needs, so they need to work for you and they can be changed around if they're not. The available information and the risk question will drive the selection of tools, so it's important that you do that work up front and make sure that you have framed your question well. So we talked about basic facilitation and charts and brainstorming and the Ishikawa, these fishbone diagrams, so these would be some of the more simple ones. One of the more common tools that are used are risk ranking and filtering. We'll have a look at those in a minute. A more complex one is our preliminary hazard analysis, or PHA. FMEA, you probably might have heard of. Failure mode, effect and criticality analysis, FMECA, is the same as FMEA, but you're adding in the criticality part to it. Risk analysis and mitigation matrix, the RAMM. Hazard operable analysis, hazard analysis of critical control points. So all of these are different types of tools. You may never see any of them again. You might use one all the time that you find the most useful. You might use a range of them. You might use them interchangeably. This is what the Ishikawa fishbone diagram looks like. So you start off with your headers, identify each risk and verify the potential risk in relation to the risk question. So you'd list off your things here and you'd basically brainstorm then all of your categories alongside it. Assess the frequency of occurrence and the potential severity of each risk. So this is a really good tool to brainstorm all of your different parameters or components to your risk. Risk ranking and filtering is one of the most commonly used ones, and it's a nice, simple, easy one. So you've got your risks identified as risk 1, 2, 3, for example, and you've got your probability, which we talked about in our previous lesson, the likelihood that something is going to happen. We've got also then our severity. If it were to happen, how serious would it be? So we've ranked them from high to low. And this is our matrix here. So we've got our increasing probability, this would be low, medium, high, and our increasing severity, low, medium, high. So if we've got a low probability here, meeting a high severity here, on our matrix we're going to get a 3, which is our medium score, and so on for each risk that we have. Risk ranking and filtering is a simple and intuitive analysis. The user defines and scores it. It can be very easily adapted. Once each risk is identified, the likelihood or the probability is estimated and scored, and the severity is estimated and scored. The overall risk then is determined from the scores. Risks ranked and filtered using criteria for the circumstance. So PHA is your preliminary hazard analysis. It's a little bit more in depth of a tool. It's very like risk ranking and filtering, but it takes the analysis one step further by adding more detailed descriptions, and it also gives action thresholds for what we're going to do if we get a certain score. So you can see here when it defines your severity term, it actually defines in words what that actually means to us. So it makes it a lot easier if you've got kind of more complicated problem or analysis to make. that everybody will be scoring the same because there's more detail around it. So severe, it's defined here as potential death or permanent injury, and you can put whatever is necessary here depending on the risk assessment that you're carrying out. Negligible is potential minor discomfort, but it's not permanent. Then the probability, the frequency, is where you've got continual occurrences, and your remote then is defined as where you have isolated occurrences possible and you don't expect a reoccurrence to happen. So you can use any wording here in your preliminary hazard analysis. So when you assess your hazards, then you are going on your frequency and your severity, and that gives you your score here so you know where you stand. So the wordings can be based on historical data. FMEA then, failure mode and effect analysis. So again, you can see there's a lot more detail put into place around our descriptions of our categories. Again, we've got our ranking 1 to 10 in this case. You can use any ranking that you'd like. The severity then is described, your probability is described, and then we're also taking into account our detection limits. If we've got a very high detection limit for something, we want to count that in as reducing our risk. If we've got a very low detection level of something, that's going to increase our risk. So you'll see here we have some blank spaces, and that is just for the simple reason that we don't have the same number of descriptions for each category, and that's okay if that's the case. So just to give you an overview then, the risk ranking and filtering. The risks are listed and they're evaluated for severity and their probability. A matrix then is used to rank the final risk, and it's a very intuitive tool. Preliminary hazard analysis is risk ranking and filtering, plus adding description to the terms, usually in words like high, medium and low. And then FMEA is preliminary hazard analysis plus putting in your detection, and it's usually in numerical form, so you're usually talking about risk priority numbers, RPNs. So we want to determine our risk factors in step 4. Again, we've talked before about our severity. What are the factors which must be considered that will have an impact on the patient compliance, the company, or other consequences? The probability, what is the likelihood that that impact on the patient compliance or company will occur? And detection, can you detect that risk? So we just mentioned there in the FMEA, detection is coming into play. If you can detect the risk, you're going to reduce your likelihood of occurrence or reduce the severity potentially. But we must remember when we're doing our calculation, if you have a low detection rate, that is equal to a high risk. So we must remember to score it in the right way. So this is decreasing detection. So we take our risk evaluation score, which we've already calculated, 1 to 9 in this case, and we multiply it out by our decreasing detection levels. So we can use any scale that we want in order to determine our risk. If we can use high, medium, low. We can use linear, 1, 2, 3, 4. We can use exponential, 1, 2, 4, 8 if we need to get a greater divergence of our numbers. We can use logarithmic. We can make up our own scoring system. And just to remember, if your numbers are all even, you won't have a midpoint. And if that might not be an issue for you, but if you need a midpoint in order to differentiate, you might want to have a little think about what scale you're using as well. Tips for defining your scales. Within each scale, allocate numbers so that the overall scores have sufficient differentiation. It's no good if all of your scores turn out to be 4. Consider the following. Choose the risk factor, your severity, your probability, or your detection level that needs the most emphasis, and that would be different depending on what you're assessing. For that risk factor, allocate higher numbers or words so that risk factor will have a greater impact on the overall scores. If you know something is more important and more critical, make sure that you weight it that way because that's what you want to see in your final results. Again, if you have a known medical issue, the scale of the severity will have the highest numbers relative to all the other risks that you're talking about. Define your risks terms or generate your matrix. For your preliminary hazard analysis and your FMEA, consider the risk factors which were determined in your step 4 and describe for each number or word the criteria. For your risk ranking and filtering and your PHA, develop your matrix. So in step 7 then we want to determine our action threshold. So once we get all this information, what are we going to actually do with it? So our high risk must be reduced. Intermediate risk needs to be reduced to as low as reasonably possible. Low risk needs to be reduced to as reasonably low as possible, considering your cost benefit. You're not going to spend a huge amount of investment in time, resources on making a low risk slightly lower. You want to concentrate your efforts on the high and the intermediate risks. If something is trivial, it's generally an acceptable level of risk and you probably will leave it as is. So you might define up front, well, if our risk priority number or RPN is greater than X number, so 10, 20, whatever the number you decide, then we need to take action. That's another way you can do it. So once you have done that, you apply your tool. When you initially apply your tool, you take a critical look at your outcome and you review your factors and scales. It is very tempting and it would be easy to manipulate your tool to get the desirable answers that you want, but don't do that because it undermines the whole basis of this being a logical, scientific analysis of your risk. Step number 9, defining mitigating measures. So we need to consider measures or actions that will decrease the severity, so stop failure before significant consequences occur, so before we have a reject or before we have a recall. So where we can decrease the probability, where we can inspect a defect of a batch out, or we can increase our detection, so we can move from a manual to a machine inspection, for example. After we implement these measures, we need to reapply the tool if applicable to show that we have mitigated our measures. So this is just an example for a preliminary hazard analysis. If we've got risk number 1, and we had given that a high risk, so we need to put in some mitigating measures. So a risk reducing controls. So what we've done is we put in place some new SOPs with tighter controls around it. We've also added in additional cross checks. So that is changing our frequency to remote, and our severity is still severe if it happens, but we're more likely to detect it. So our risk is now reduced to intermediate from high. Step number 10 is to document and approve. So there are lots of different ways that you might document a quality risk management. It could be part of your validation protocol, it could be part of your validation master plan, it could be part of a deviation or a change control, or it might be documented on its own. Either way, the detail behind the decisions that you made need to be documented in a comprehensive way, and they need to be signed off and reviewed and approved. Risk review. At the end of the process, on an ongoing basis, there tends to be a risk review, so QA would be involved in that. Risk reviews would also occur through internal audits on a site. You can be guaranteed that inspectors coming on site, either from customer suppliers, corporate or regulatory authorities, will be very interested in how you manage your quality risk management. Risks then will be reviewed indirectly through change control and deviation system. Risk-based approach examples. QRM has proved to be extremely useful for assessing process risks. So that is identifying what your CQAs and your critical process parameters are. So this is 2 examples of how that was done using 2 different tools, so you can just see the difference between them. Example A is using risk analysis and the mitigation matrix RAM, and example B uses FMEA. So our process is a simple process flow diagram for the production of MABs, monoclonal antibodies. Critical to quality attributes are defined and ranked as low, medium or high risk to a patient's health. These could be things like your myoplasma, viral contamination, identity, acidic variable levels, the yield, the concentration assay, the purity assay, the visual appearance, osmolality, pH, residual host cell protein, residual host cell DNA, bioburden, endotoxin, viral clearance. Example A, your risk analysis and mitigation matrix. So the first thing we want to do is identify our CPPs. So we do a flow diagram of the overall process, which we've done. We're going to list our possible CQAs, or critical to quality attributes. We're going to identify the unit operations that they apply to. We're going to construct a matrix of our CQAs versus our unit operations, and then we're going to assign a low, medium or high risk to those. Risk, when we're talking about risk, we're talking about risk to the patient of harm. So we've listed our CQAs. Again, there are more, but this is just for the example. Then we're going to list our unit operations across the top here. And then we're going to assign each one a low, medium or a high risk. So you can see here we've ended up assigning 4 high risks and quite a number of medium risks as well. So that gives us where we need to work next to try and reduce our highs down to mediums or to lows. So that is your RAMM. So FMEA for your same process. So here we want to identify our unit operations for the process that are critical to the product quality. We want to identify the steps in the overall process. We conduct our FMEA. Failure here would be things that would affect our product quality. Failure to attain the accepted product quality is equals to a high risk of harm to patient. And we will assign a risk priority number, or RPN, to each unit operation. Your risk priority number is calculated by multiplying your severity by your occurrence by your detection. So that's S by O by D. And we will assign a cut-off RPN number. So what are we going to do if we reach above this RPN number? That's where we need to take mitigating actions. So our process flow remains the same. Here we've defined our scores. So in this case, we've gone from 1 to 10. So we've got quite a high level of differentiations. So you can see in our definition, we're at number 10 for severity. We are rejecting the lot because of a very high risk to patient safety. It's a hazardous drug. And at number 1, we've no effect to very low effect in product quality. In occurrence, 10 at the highest end of our scale, it's expected to occur greater than or equal to 80% of the time, and at number 1, or equal to 1 to 5% of the time. Our detection levels at number 10, we have no way to detect it, so that's a very high risk. At number 1, it's detectable before the process begins, so that would be a low risk. So a risk priority number, as you remember, RPM is equal to severity S multiplied by occurrence O multiplied by detection D. So if we just take one example here, our depth filtration is our process step. Our failure mode, our filter gets plugged faster due to pressure breakdown. The effect of the failure then is effective filter area requirement increases, so the process economy increases. We're going to score the severity of that happening at a 7. The potential cause is improper scale down studies for area sizing and pressure gauge not calibrated. So the likelihood of occurrence is a 4. And then our current controls that are in place, documentation of the pressure gauge, calibration report prior to the processing and conducting the scale down studies for area sizing. So we're going to give our risk of not detection a 2 because we have quite good controls in place. So when we multiply our 7 and our 4 and our 2, we end up with 56. And our actions are going to be include in the protocol procedural control. Okay, so we've scored 56. Up front, we gave our RPN number a risk cutoff of 30. So you see all of the characteristics here that we risk assessed. None of them have met the category of 30. So that would mean that we're not accepting any of those risks and we need to go back and put further actions and mitigating criteria in place. Mitigating action to reduce your risk and then reassessing it. So when we did our first risk assessment, we have a matrix that looks a little bit like this. And you see we've quite a lot of red in it and we've quite a lot of yellow in it. We go and we put a lot of actions into place and make some process improvements, system improvements, add some further checks and detection levels. And we've managed to reduce the number of red marks down in this one. When we reassess our risks, we find we still have some red high risks that we're not accepting. We need to do some more mitigation. So we need to add more actions in place so that we can reduce down our risks to this one here. When we reassess our risks, on this occasion then we've got rid of all of our high risks and we've reduced the number of yellow risks also. So we are much happier to accept these risks. So some further reading for you. Over to you. Can you identify some of the 10 steps to approach a QRM? What are some of the tools you could use for a QRM? What approach would you take to performing a QRM on CPPs, critical process parameters? Thank you very much for your time and attention. We'll see you for the next one.